Hi everyone, a very warm welcome to you all to the chemistry sessions. So in this session we are going to discuss a set of 10 questions with the chapter carbon and its compounds. So be ready for it. Let's start with question number 1. What do we have? Okay, in the question number 1, so it is going to be 1 mark question, fine. As per the instruction, the second question is also for 1 marks. What is the next higher homologue of methanol? So what is it? What is a homologue? That means from the similar series. See here, the series is of methanol. That means I need to include the alcohol as well as the next series will be having 2 carbons. It started with the 1, I need 1 more, okay. So that will be the next higher homologue and it is going to be, yes, what it is? C2H5OH or let us just expand it, CH3CH2OH. This is going to be ethanol, the alcohol, okay. So just 1 liner is required here in this question, no extra marks for any extra lines, okay. Now, so that was question number 1. Let's move on to the question number 2. Again 1 mark question. What are the 2 properties of carbon which lead to the formation of a large number of carbon compounds? So you must have seen most of the things around yourself is made up of carbon. If I just talk about the organic compounds, that means the living organisms, that means human beings, your body, my body, everyone around us which is living, that means including plants, in fact animals also. So why this carbon is so versatile? What kind of a property will it be showing so that it is leading to the formation of so many compounds? So first of all, it has got 4 valencies, yes. It is having 4 valencies. That means it's also known as tetravalent. What is this tetravalent term? Tetra means 4, valent means having the valencies. That means it is capable of having 4 vacant spaces which can lead to the formation of various kind of structures having each carbon capable of joining with 4 substances. So that is how it can form a gigantic network of atoms, okay. And the second thing, the most important as I told you, is the property of catenation. Catenation is what? The self-linking property. 1 carbon can be linked with the another and so on, forming a lot of chains, a lot of branches, a lot of cyclic rings as well. So that is why it leads to the formation of very big structures having millions and millions of carbons, okay. So that is what the 2 properties are. You have to form it on your own, the answer, fine. So that was question number 2. Question number 3. So 3 to 4 would be for 2 marks. How would you convert? Now this is an important one. You know, this kind of questions are very frequent in 11th or 12th standard also. But here it's a bit basic. In those you will be having many reactions in just 1 question applied. So here what do you see? Ethanol into ethene. That means let us just try to write the formulas of each one of them. What I need to do is I just need to tell 1 particular process which will be leading to the conversion of ethanol into ethene. And this process, this chemical reaction we have studied in the lectures, fine. So first of all, ethanol. What is ethanol? We just have discussed alcohol. I need ethene out of it. This is the ethene. So what can be the possibility? I just need to lose the water right here. For loss of the water, I just need few drops of concentrated sulfuric acid along with heating. Loss of water will take place and we get an alkene, a dried up product. So it is concentrated sulfuric acid. Over the arrow I have mentioned and a bit heating, how much? 433 kelvins. And that is how you get the product. Got it? So this is one of the reactions. And you know, just for your information I am telling what is the name for this reaction. Hydra means water. I just need to remove the water right here, minus H2O. So the reaction is known as dehydration, the removal of water, okay. So you can write this down, dehydration. Next one, propanol into propanoic acid. So propanol, The next homologue for ethanol. So it is going to be propanol, having 3 carbons and ol means OH, into propanoic acid. That means CH3, CH2, COOH. OH means carboxylic acid. Fine. Now, conversion of alcohol to the carboxylic, one and only reaction, oxidation reaction. So it is going to be oxidation reaction. And what could be the possible reagent, that secret agent I want to take, which leads to this conversion? So that secret reagent is alkaline KMnO4, or maybe acidified K2Cr2O7, and not just alkaline, I can take up acidified KMnO4 as well. Acidified KMnO4 can also be a part of it. Fine. Now, this one done. Name the process in each case and write the equations for the following reactions. We have already done this, okay? So that completes question number 3 as well. Now, let us move on to the question number 4, okay? So the question number 4, again 2-mark question. Yeah, and this is going to be interesting one. Give the IUPAC names for the following. Okay, so see here in the very first question. So I just need to find out the names for these, okay? And these are the expanded structures, as I told you. If you want to name a substance, just try to condense down the little bit, okay? Not that super condensed formula, but a little condensed formula would do, okay? So first one, so this carbon, right? And CH, this H I can write it down here. As I told you, it is bute, not N-butane, because N-butane leads to the straight chain. So this is going to be the tertiary butane, yeah. So it is just the tertiary butane. It's basically another format, the branch format of N-butane. Fine. Next one, right here, this one. Okay. So this is going to be CH3, CH, CH2, CH3, and this one CH3. Now, what is this going to be? Can you tell me? The name for this compound. Okay. So let me just tell you one thing over here, one very important fact. That is how to actually name, how to actually write the IUPAC names whenever the branch comes. See here this tertiary butane which I have mentioned. The tertiary butane is not as such the name, as such the IUPAC name which is used, okay. So let us just try to have the names for it. Try to listen to me very carefully, because this is a new thing which you are learning over here. See here. What do I need to do? Just the very basic, hear me out. Which is the longest possible chain? How to find out the longest possible chain? Longest possible chain of carbon, okay? Of carbon I need to find out. So the longest possible chain, second thing which you need to remember is, while choosing the chain, do not lift your pencil or pen or whatever you are using, okay? So do not lift the pen. That means you have to draw a straight line. How? See, longest possible chain, 3 carbons or 1, 2, 3. 3 carbons, it's the same thing, because in the middle one there will be 1 group attached. Here also in the middle one group attached. From here also I can choose only 3. But if someone is trying to do something like that, 1, 2, 3 and 4, no, here I will have to lift my pen, my chalk, right? So I will just choose this longest possible chain which I have found out without lifting my chalk, okay? The straight one I have chosen. Out of the 3, any one I can pick. So the straight one. Now what will happen? Just try to number number the chain, okay? And fourth point to be kept in mind while numbering. The branch should be given the lowest possible number, okay? Lowest possible number, fine. Let's see here. So I need to number this chain as 1, 2 and 3, fine. Now, if I would have numbered from this side 1, 2, 3, then also this branch will be getting 2 number. So I can just do it in either ways. So on to what group do I have? So tell me here, what is the group here? CH3 dash. If this is methane, then this is going to be, if this is alkane, this is going to be alkyl. If this is methane, this is going to be methyl. Fine. So on to the second position, I have got methyl, 2 methyl, and the total chain how much? Prop and ane. Getting it? So that is going to be the proper IUPAC name. I hope everybody has learned this. Now coming on to this, I need to first of all select the longest possible chain. See here, 1, 2, 3, 4, yes, or 1, 2, 3, 4, or 1, 2, 3, no, this is not possible. So two options are there and each one of them is similar. So I am just choosing the straight chain. Let's number the straight chain, and to be kept in mind, the branch should be given the lowest possible number. So I am numbering it from 1, 2, 3 and 4. On to the 2 I have got, again the methyl, 2 methyl, total carbon chain how much? Butane. This is the answer. Fine, got it? So yeah, my question number 1 done, okay. Question number 2 done. Coming on to the question number 3, this is going to be interesting. CH2, double bond CH, single bond CH3. What is it? Prop and a double bond? Propene is the answer. Now, fourth one. Right? So it's a triple bond right here. That means having 3 carbons and triple bond, 3 means prop and triple bond means ine. So this is going to be propyne. Cool? Got it? So this was an interesting question and you have learned the new thing, that is how to actually name the compounds right here. Okay? So these rules should be kept in mind. These are applicable everywhere. Now moving on to the question number 4, okay 5, 4 is done. 5 to 8 3-mark question. How would you test for an alcohol? That what can be a possible test which will detect that this is an alcohol? So what you can do is, first reaction, just wait. Yeah, so first reaction can be, if I just try to react this alcohol with acetic acid, yes? What is the possible product which is formed in the presence of concentrated, few drops of concentrated sulfuric acid? Do you remember? A fruity smelling liquid, pleasant smelling, that is an ester, CH3COO C2H5. Fine, got it? So that is a very, very good test for alcohols plus H2O. Yeah, and this is going to be an equilibrium reaction. That means it is going on here also and to the back side also simultaneously. Fine. Now, this is going to be an ester, pleasant smelling. Fine. So first part done. Second part, give the harmful effects of drinking alcohol. What is the harmful effect? It will lead to drowsiness. Yes. In that drowsiness, you can perform any random activity. Yeah. So you must have heard those cases also, that while you are drunk, you should not drive a vehicle. It can lead to various accidents. Yes. So that can be a possible harmful effect of it. So these are the different. It lowers down our central nervous system. The organs, they also start doing all the activities very slow because the signals are not that much faster at that moment, which reaches to our brain. Fine? Okay. So these are some of the effects, you can just mention it. Explain why methanol is much more dangerous to drink than alcohol or ethanol. So basically methanol, when it is consumed, gets converted into methanol. Now this methanol, it reacts with the cells and coagulates them. This will lead to eventually the death. Fine? So that is why it is mixed usually in the industries along with the alcohol, just in order to avoid any consumption of it. Fine? Okay. So that was question number 5. Now moving on to the question number 6. Again a 3-mark question. Yeah. Name the reaction which is usually used in the conversion of vegetable oil to fats. Yeah, I have told you this reaction, vegetable oil to ghee. Yes. Fats and oil, it's one and the same thing. It is nothing but ghee. Explain the reaction involved in detail. So basically this is an addition reaction. Yes. Addition reaction, and yeah, so the name of the reaction is hydrogenation. Hydrogenation of vegetable oil. And you know what kind of a hydrogenation it is? Using a catalyst. In addition reaction, we use up a catalyst, usually nickel. Yes. And what can be the possible reaction? Since I need to add up the hydrogens from any alkene or and in fact from an alkyne also, we can just convert it into alkanes, and that is hydrogenation reaction using a catalyst. That is why it is known as catalytic hydrogenation. Important term to be learnt. Fine. So this is done. What is saponification? Write the chemical equation for the reaction involved. Name all the substances which take part in this process and also those which are formed. Fine. So basically you need to write down the saponification, which is the reverse of esterification, which I just did, the formation of an ester. So I just need to reverse it down. That means let's take up this ester. Try to react it with NaOH. Then there will be the formation of soap. I get the alcohol as it is plus the sodium or potassium salt. Whenever I am using sodium hydroxide, we will be getting sodium salt of acetic acid. Whereas if I use KOH, I will be getting the potassium salt. So that is what the saponification is. Fine. And name all the substances. It was ethyl acetate. This is the name for this ester. This is alcohol. This is sodium. Sodium acetate is the name. Fine. Formed from the acetic acid. Now this is B, which is done. Why does micelle formation takes place when soap is added to the water? You know it very well. See here, soap is the long chain fatty acid, the ion, the sodium or the potassium salt of long chain fatty acid. Long chain means having a very long carbon. So this is just a bond line representation of that carbon having a head which is ionic. Yeah, and this head can be any ion, Na plus or K plus. So this is going to be non-polar part. That means what? Hydrophobic. This is hydrophobic, this is hydrophilic. So what happens is, there is the surface having a water oil droplet which is stuck. So what will happen? Hydrophobic part is loving this oil droplet. Okay. So it gets attracted towards it, something like that. These ionic ends will be towards the solution, which are water molecules over here. Yes, both are friends, and that is how it entirely covers up somehow this oil droplet and just tries to fetch it out. It fetches it out, and finally we will be getting all the oil removed from the surface. Okay. So the detail for this you can just refer to the lecture where I have shown you the entire process in a detailed version. Now this is how the micelle formation takes place. Now will a micelle be formed in other solvents like ethanol also? Is it so? Yes, it can be possible. Why? Because the solvent, what they are telling here is C2H5OH, this is also polar, okay, and this is also hydrophilic, that means water loving. This is hydrophilic and these ends are also ionic, so they can interact very well. They have become friends also. So in the case of ethanol also, I can have the similar process, but it can be a little slow. Why? Because see, it has got the non-polar part, a similar kind of a carbon chain as well. So the process may be a bit slow. Fine? Okay. So that completes part number C as well. Fine. Now question number 6 done. Let's take up question number 7 in this case. Here, write 2 points of difference in the structures of the diamond and the graphite. So we have discussed the structures already. Diamond and the graphite. Difference in the structures, can you tell me? Diamond, each and every carbon is associated with 4 carbons. Okay. So if I talk about diamond and if I talk about graphite, so in diamond, all 4 positions are occupied, yes, 4 valencies, whereas 3 valencies are occupied in graphite. Now the next point in the structure, so it's a giant network, yes, of covalent bonds, whereas in this, these are hexagonal rings stacked. Cool? So these are 2 points. Explain why graphite can be used as a lubricant, but diamond cannot. Why? Because graphite, since it has only 3 positions occupied, 1 is still left, these hexagonal rings are stacked onto one another with very weak bonding, and that is why these layers are slippery. And due to the slipperiness, it is soft in touch, okay. That is why it makes graphite as a very good lubricant to be used, but diamond, on the other hand, having this gigantic network of covalent bonds, will be very, very hard. Fine. Explain why diamond can be used in the rock drilling equipment, but graphite cannot. It's just the similar property. Since the diamond is very hard, so it can be used for drilling purpose, whereas graphite is very soft. You must have seen the lead of pencils. It is very soft. It can break easily. So that is why I cannot use it as drilling. It's common sense. Fine. Now, question number 8. Describe the structure of the graphite with the help of a labeled diagram. So how can you draw the structure of a graphite? You can just have these hexagonal rings somehow like this. Okay. That can be represented as layer 1, and a similar kind of a layer you can draw below it, yes, something like this. And these layers are somewhat attached like this. Each and every corner will be stacked properly, so that is how you need to represent the bonding as well. This is the bonding, yeah, so that is how you have to do, something like this, okay. Although it's not a proper one, with the help of a scale you will be able to do that properly, fine, like that, okay, fine. So these are, you can just represent, this is layer 1 and this is layer 2, those are stacked onto one another, fine. So A part done. Why is graphite a good conductor of electricity, can you tell me? Because 3 positions are occupied, still 1 left, and due to that vacant position 1 electron is also free to move. Since the electron is free to move, it can conduct electricity very well. So due to the free electrons, cool. But diamond is not a good conductor because there are no free electrons in it. State any 2 uses of graphite. First, we just did in the previous question, that is as a lubricant, yes, and the second one can be used in pencils, yes, or maybe some equipments or some very special kind of pencils which are used to draw those sketches, okay. In that also graphite is very prominently used. Now, here, question number 9, a 5-mark question. Now, what is meant by a functional group? Explain with the help of an example. So, the functional group is the one actually, it's a kind of a group which when attached with a pure hydrocarbon chain, it will change the entire chemical nature of it. Fine. Explain with the help of example. See here, this is ethane, but the moment I try to attach one functional group to it, making it CH3CH2OH, it turns out to be alcohol. Earlier it was oily, now it has turned out to be somewhat polar and somewhat water loving. It can very well get dissolved in the water, but it cannot. So, the entire properties changed, all the reactions will be changed. Fine. So, it is a kind of a new species, new chemical substance which has been formed. So, that was an example. Write 3 common functional groups present in the organic compounds. 3 common, number 1, alcohol, yes. Second one, aldehyde. Third one, carboxylic, done. And you need to write the formulas as well, OH, aldehyde, COOH, got it? So, B part done. Name the functional groups present in the following, we just have done. See, this is what? Carboxylic acid, this one, aldehyde, this one, alcohol, okay, and next one. So, see here a group which is somewhere in the middle, that means this is definitely be going to ketone, Next one, name the functional group which is always occurring in the middle of the carbon chain. Middle of the carbon chain, the ketone, the carbonyl group is always in the middle, yes, and the 2 valencies, or I can say the vacancies are there, which will accommodate 2 R groups, 2 alkyl groups, fine. So, this is going to be again ketone is the answer. So, this one also done. Draw the structure for the following compounds. Now, this is going to be interesting. Ethanol, al means aldehyde, eth means 2 carbons, a total of 2 here including the functional group. Butanol, having 4 in total including the functional group. Done, butanol. Propanol, oh, all of them are aldehydes only. So, prop 1, 2 and 3, done. Pentanol, 1, 2, 3, 4 and 5, done. Each one of them containing the similar functional group, that is the aldehyde, and we have got this right. Fine. Okay. So, let us rub this off and move on to quickly to the next question, the last question of this round. Question number 10. You are given the following molecular formula of the hydrocarbons. So, it is the super condensed version of the formulas right here. So, you need to figure it out. First one, which formula represent? Cyclohexane as well as hexene. Okay, cyclohexane, can you draw it? Yes, I can draw it. This is cyclohexane. How many carbons? C6. How many hydrogens? You need to calculate it. So, just by looking onto the formulas, it will be very difficult for you to judge. So, what instead you can do is, just try to form the formulas from the names given itself. Okay? That will be an easy process. So, these are the hydrogens 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. C6H12 is cyclohexane. Do we have? Yes, we have. Next one, hexene. That means this, H2, H2, H2. So, you will be surprised to know that this will also be having the similar condensed formula. Yes, C6, H how many? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Just wait. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay. Not 11, but the last one should have been 3. So, that means H12. similar. Okay, got it? Which formula represents benzene? So benzene we know. I told you the structure for benzene. This is having carbons at the corners and hydrogens only one. That means C6H6 is the formula. C6H6. Done? B part done. Which three formula represent open chain unsaturated hydrocarbons having double bonds? Unsaturated I should have first of all. That means having double bonds. Okay, they have mentioned it also. And I need an open chain. So for that, again, no need to go into the detail for each and every compound which is given over here. Just try to go with the formula. What is the general formula for alkenes? I had told you CnH2n, that means twice of it. It will be very easy for you to judge. Twice, where can you find twice? C5H8, no it is not. 7 2s are 14, yes this is. So this is 1, 5 2s are 10, this is 1. 7 2s are, is it 12? No it is not. 6 2s are 12. Yes, this can be, and this is. So there are 3. They had asked for 3 only. Fine. Which two formula represent unsaturated hydrocarbons having triple bonds? Now for triple bond, I should need CnH2n minus 2. Yes. So see here, 7 2s are 14, minus 2 is 12. I got this one. Fine. Next one, 5 2s are 10, 10 minus 2, 8. C5H8. Okay. Yeah, the last one. Which three formula can represent the cyclic hydrocarbons? Cyclic. It can be saturated, it can be unsaturated. So one is the benzene. Another is cyclohexane. Yeah, this was benzene. This is cyclohexane. Fine. Next one, C5H8. Which three formula can represent hydrocarbons? Okay, cyclic hydrocarbons. Okay, let us just test over here. So, one is this, another is this. I need the third one. So, see here, one option is C5H8. Can I make any compound related to that? Let's see. C5 and H8, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Can I do that? Yes. This is also done. Yes, this can be a cyclic compound. So, C5H8 can be one, or maybe just the cyclopentane, C5H10 also. This can be a possibility. In fact, in both of the cases, we can have a cyclic ring, but 5 or 6 membered would be the stable one, not the 7. Okay, so just remember this thing, that the rings beyond 6 number will be a bit unstable. So what you can consider is either this or this. Fine. So that completes my entire set of 10 questions. I hope everybody has understood, especially this particular question. It was a bit typical one. And just try to remember the rules which I have told you in the session in which I had told you the IUPAC nomenclature, how to actually write down the names of the compounds given whenever there are branches present. So that is going to be typical for you, and you can just try out few examples related to that just in order to practice a bit. Fine. Still, if you've got any doubts, you can approach me. I'll be available for you, clearing all your doubts. Have a nice day.